So today we're going to finish up chapter 1. We're going to cover section 6. And in this lesson, we're going to learn how to describe angle pair relationships. And here, this is going to be a really important lesson because we're going to be using all of these angle pairs quite often in our proofs. And it's also nice standardized test material. So you might get questions on an SAT or a PSAT with the information in this section. So the first 3 types of angle relationships we're going to talk about are complementary, supplementary, and adjacent. Now you've probably heard about complementary and supplementary back in middle school or in elementary. And the key word here for complementary and supplementary are that they're going to be only 2 angles. And for complementary, it's 2 angles whose measures have a sum of 90. And supplementary are 2 angles whose measure have a sum of 180. Now, when we're looking for these 2 complementary angles or 2 supplementary angles, they do not need to be adjacent angles. And what I mean by adjacent is they're 2 angles that share a common vertex and side, but have no common interior points. So the word adjacent means next to. So adjacent angles are 2 angles that are next to each other. So when I'm looking for a pair of complementary, they don't have to be in the picture next to each other. So down here in the pictures, notice right here, these are 2 adjacent angles. Notice if I outline angle 1 and then outline angle 2, notice that they both share this side in the middle where there's both a red and a blue line. So adjacent angles are going to share a common side, and they're also going to have a common vertex, and that's going to be right here. So that would make adjacent angles. Now, they can't overlap, and that's what it means by have no common interior points. So the 2 angles just have to be next to each other and they can't overlap. So I can also identify complementary angles that are adjacent and complementary angles that are non-adjacent. So for example, if this angle here was 20 and this one was 70, complementary adjacent angles would be 2 angles when you add them. They add up to be 90 degrees. And I could have this same scenario when they're not adjacent. This one could be 30 and this one could be 60. I'm just looking for 2 angles when I add them, and that sum gives me 90 degrees. That's what makes them complementary. The same thing can apply to supplementary angles. They're just 2 angles that when you add them add up to be 180. They can either be adjacent or non-adjacent. So for example, if I told you this one was 120, then I could figure out the missing one by subtracting it from 180, and this would be 60. Same thing here. Let's say this is 110, then this one would be 70. So just any combination of when you add them, you get 180 degrees. Now, you may end up using this information when we're writing proofs. So for example, maybe a statement in a proof could show that you could say that angle 7 plus angle 8 equals 180. And your reason might be that they're a linear pair, it might be that they're supplements, whatever reason could justify that statement. So, and we could do the same thing for complementary. We could say that angle 3 plus angle 4 equal 90. And then maybe my reason is that they're complementary angles. Now, one little trick, and if you're struggling with keeping track, which one adds the 90 and which one adds the 180, I sometimes try to come up with little tricks to help you remember. So to tell the difference between complementary and supplementary, I sort of sing the ABC song in my head, and then complementary is here at the C, and then if I keep singing E, F, G, H, I, J, K, L, M, N, O, P, and then Q, RS, and this is where the supplementary are. I also think of this as like if I were writing out numbers, 1, 2, 3, 4, I think of the C as the smaller number and the S is the 180. As long as you remember 90 and 180, that will help you. Or another way that I do it is if I start to write the first, say 4 letters of the word complementary, and if I just add a little line here, it sort of like looks like I made a 90 out of that C, the CO, so that would be 90 degrees. And then if I take the word supplementary, if I start writing the first couple letters, and if I just put a line this way, it looks like I make an 8. So this would be the 180. So whatever tricks are going to help you, just know that you need to know that complementary are 2 angles that when you add them, give you 90, and when they're supplementary, 2 angles, when you add them, they give you 180. So again, whatever technique will help you. Pretty good there? All right, let's try to identify some complementary, supplementary, and adjacent angles from a picture. Let's go to the next slide. So again, we're looking for 2 angles that when we add them, give me 90 degrees. So again, they don't need to be adjacent. Now, in the first set of angles here, notice they're both sharing vertex A. So I need to use 3 letters to name the angle in this picture. In the other angle there, that RST, I could get away with just using 1 letter because there's only 1 angle with a vertex of S. So my 2 complementary angles, or if I try to test it out, if I try to add 32 plus 58, I get 90. So those are going to be my 2 angles that are complementary. So I can either call this BAC, or I could reverse it and say CAB, along with angle RST, or I could reverse it and say TSR, or I could just call it angle S, because there's only 1 angle sitting there at vertex S. So just match one of these with one of these, or here, or the same thing with the letters in reverse. So those would be your pairs of complementary angles. For supplementary, I'm looking for the 2 angles when I add them that are going to give me 180. So I can see that I have 122 here, and I'm going to try to add it to the 58. So when I add 122 plus 58, this gives me the 180. So those are the 2 angles that I'm going to identify as being my supplementary. So again, for the DAC, I need to use 3 letters. I could reverse it, CAD. And then again, for this angle over here, again, you can either pair it with and call it angle S, or call it RST, or reverse it, TSR. So a pair of supplements could be that one, could be this one, just as long as you pick one from here and match it with one from here. And those are your supplements. Adjacent angles are 2 angles that have a common side and a common vertex. So my adjacent angles are sitting right here. So I could, again, name them with 3 letters. So you can say that angle BAC along with angle CAD. Those would be a pair of adjacent angles, or if you wanted to reverse the letters, CAB, and then reverse it to DAC. And again, don't forget to put that little angle symbol in front, or write out the word angle in front. So these share a side. They're both sharing side AC, and they also have vertex A in common. So the next one is a real life application, tying it to sports. So here it says, when viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. Find the measure of BCE. BCE is here. Here's B, here's C, here's E. This is the first angle we need to find the measure of. And then the second one is the ECD, which is going to be here, here, and here. And notice they both have expressions, and we were told that they're supplementary. So here's where you need to know that supplementary angles are two angles when you add them, they equal 180. So I'm going to take the two expressions, the 4x plus 8, add that to the x plus 2, and set my equation equal to 180. So here's where you have to bring in your vocabulary to know, do I set these expressions equal to each other? Do I add them and set them equal to 180? So supplementary angles aren't necessarily congruent. Now, if they're both 90-degree angles, then they're congruent and supplementary. But most of the time, they're going to be two different numbers, and you will add them and set them equal to 180. So I'm going to go ahead and combine my like terms. 4x plus 1x gives me 5x. And then I can add my constants. 8 plus 2, that gives me 10. Drop down's the equal 180. Subtract 10 from both sides. 5x equals 170. And now I divide by 5. And x equals 34. Now, again, the question didn't ask me to just find x. I need to go back now and find the measure of each angle. So it wants me to find the measure of angle BCE, and BCE is the 4x plus 8. So I'm going to take out x, replace it with 34. I'm going to multiply it by 4. 4 times 34 gives me 136. And then I'll add that to 8, and I get 144. I also need to go back and find the measure of the other angle, ECD, and that's represented by x plus 2. Replace x with 34, add the 2, and I get 36. Now, technically, because these were supplements, once I found the first angle, the BCE, the red one, I could have just subtracted that from 180, and that would have given me the blue angle as well. But again, different ways to double check your answers. Again, these two added together need to equal 180. If they do not, you've done something wrong, and you need to go back and check your work. They do equal 180 when I add them, so I did the problem correctly. So my answers are 144 and 36. More vocabulary, more special angle pairs. The first one is a linear pair. And when you have two adjacent angles, when common sides are opposite rays, they always form supplementary angles. So a linear pair, when you add the two angles, they're always going to add up to be 180. Vertical angles are two angles whose sides form two pairs of opposite rays. So you can form vertical angles by intersecting two lines. So let me show you the linear pair. So if I outline angle 1 in red, and then angle 2 in blue, notice the definition says two adjacent angles. These are two angles that are side by side. When non-common sides are opposite rays. So notice the non-common sides, this would be the red one and the blue one. The common one is where it's both red and blue. So the non-common sides, notice, are forming opposite rays. They're both pointing in opposite directions. So this is a picture of a linear pair, and they're always supplementary. For the vertical angles is when you're going to have two lines that are going to intersect, then what's going to happen is the two angles, their sides are going to form two pairs of opposite rays. So for example here, angle 4, if I outline it, and then the other angle this way, notice I formed two pairs of opposite rays. Here's one, and then here's the other. So what we're going to learn also coming up is that vertical angles are congruent. So this angle, angle 4, is going to be congruent to angle 5, and then angle 3 is going to be congruent to angle 4, but this is coming up later on. So maybe a way to help you remember when you see a picture like this, that the name that you're going to describe them as is vertical angles. You could sort of think of this as like the letter V, and then if you put a line here, it looks like VA. So vertical, and then angles. And even if you rotated your picture, you also have the V this way and this way. So vertical angles are like on opposite sides. The vertex that they're sharing is right here. So for example, if I add some points to this, let's say I say this is A, B, C. You see those letters okay? Maybe I'll do it in black. A, B, C are these 3 points here. And then if I label this one as X, B, it's still B, and Y, I could say that angle ABC and angle XBY, these are vertical. Notice the middle letter is the same when they're vertical. Now we're going to tie all of this to algebra. We're going to get some word problems and we're going to need to translate. So here is a link to our algebra skills. Now, if you saw a word problem like this, maybe in middle school, and you hadn't taken Algebra 1, you would have probably just had to guess and test to find the measure of each angle, but now we have good algebra skills, so we're going to use that. So I'm going to go ahead and give myself a visual since one was not provided. I'm going to draw my linear pair. So I'm going to draw a line, and I'm going to split it. And it says the measure of one angle is 5 times the measure of the other. So I'm going to let X be my first angle, and then the other is 5 times the measure of the other. And I know when I have a linear pair, together these two angles are going to add up to be 180. They're supplementary. So I'm going to do 5x plus x equals 180. I'm going to add my like terms. Going to divide by 6. And my first angle is going to be 30 degrees, which is going to be right here. And then the other angle, I can either find it by subtracting it from 180 or doing 5 times 30, and I get 150. Yeah. Again, I'm translating as I read. So the measure of one angle, and I'm going to let that be x. The word is my equal sign. And then here in the problem, it said is 5 times the measure of the other. So that's where I get the 5x. Does that make sense? All right. So again, together, because I knew that they were a linear pair, I know that this is going to be 180. So my two angles are going to be 30 degrees and 150 degrees. Because again, a way you could double check is go back and add them. 30 plus 150. If this does not equal 180, you've done something wrong. Try number example 4. Another word problem. We'll translate. Now, before I tackle this, let's first figure out how we could find a complement of an angle if I know one of the angles. So let's say, remember, complementary angles are going to be two angles that add up to be 90. So let's say I split this, and let's say this one's 40 degrees, and I want you to find the measure of this other one. Whenever I have two angles and I'm told that they're complements, I know when I add them together, they're going to be 90. So to find the other one, really all I'm doing is 90 minus 40, and I can know my other missing angle is 50 degrees. So I'm going to use this fact that I'm going to use in this word problem. So here it says the measure of an angle, so I'm going to call that x, is twice, so that's 2 times, the measure of its complement. So remember, to find an angle's complement, we're going to do 90 minus the angle. This is going to be the equation that I'm going to solve. If it were supplementary, instead of 90 there, I would have 180. So I'm going to solve this equation. I'm going to distribute the 2 first. I get 180 minus 2x. I now need to get my x's together. So I'm going to add 2x. And I get 3x equals 180. Divide by 3. And x equals 60. So that's the angle. To find its complement, I just subtract it from 90. My Algebra 1 skills of distributed property. So I multiplied 2 times the 90 and then 2 times the x. Okay, and now, so this is the angle. And to find its complement, I'm going to do 90 minus 60, and I get 30. So this is the complement. And this is the angle. Yes, question?
Yes, what do you mean when you say twice? The measure of its...
So twice means times 2. And then remember how I showed you up here, when we want to find a complement, we just take whatever the angle is and subtract it from 90. Here, my angle was x. I didn't have a number for it. So that's why I did 90 minus x. And then twice was the times 2 that I put out in the front. It's just interpreting a diagram. Remember, you can never assume anything in geometry. The only thing you can assume is when it's a straight line. So from this picture that's right here, the only thing I know for sure is that all these points are in the same plane, so they're all coplanar. I also can see that points A, B, and C are on the same line, so they're collinear. I can also see that this line that I just highlighted in blue, plus this ray and this ray, they're all intersecting at point B. I can also state that I got adjacent angles here. So this angle, I could state ABD is adjacent to DBE, or I could even say that DBE is also adjacent to this one. I could also say that this point E that's here is in the interior of this angle. What I cannot conclude is that this is a right angle, even though it looks like a right angle. The only way that I can conclude that is if it had the box there. So I cannot conclude that that's a right angle. I also can't tell if B is the midpoint. I can't tell that this is congruent to this, even though it looks like it's smack dab in the middle. So without any numbers or congruency marks, I cannot assume that those are equal. As well as these two, it looks like they're equal, but unless they told me that this was the bisector, I can't conclude that those are congruent. So again, you have to be given angle measures or congruency marks to conclude that something is congruent, or if it's a right angle, it needs the box, or it needs to be labeled with 90 degrees. Later on, we're going to also learn that perpendicular lines form right angles. Let's try the last example. So here it says to use the diagram to solve for x and to find the indicated measures. Notice what I can assume here is that EFG is a straight angle. This is a straight line, so it measures 180. So these two angles here are going to form a linear pair, and they're also supplements. So in order to find the measure of EFH, which is the red one, I'm going to go ahead and set up an equation. I'm going to set 3x minus 6 plus 2x plus 16 equal to 180. These are not congruent angles, so all I know for sure is that they're supplements, and I add them and set them equal to 180. I'm going to add my like terms, so 2x plus 3x is 5x, and then I can also add the negative 6 plus 16. I get 10. And now I can begin solving by subtracting 10. 5x equals 170. Divide by 5, and x equals 34. Again, it didn't ask me to find x. It wants me to find EFH, so I'm going to plug it in. EFH is the 3x minus 6. So 3 times 34 minus 6, 102 minus 6 is 96 degrees. So the measure of EFH is 96. If it asked me to find the blue one, I could either plug in 34, or I could just subtract 180 minus 96. And then the last example, notice the little box here indicating that these are complements. So I'm going to take ABC, x plus 9, and I'm going to add that to CBD, which is 2x, and I'm going to set them equal to 90 degrees. Once I find that, I'm going to plug it back in to find ABC. Add these. I get 3x plus 9 equals 90. I can subtract 9. 3x equals 81. Divide by 3. X equals 27. And now I'm going to plug it in. ABC was equal to x plus 9. Plug 27. 27 plus 9. And my answer is 36. So again, the measure of angle ABC equals 36. If they wanted us to find CBD, I could also take 2 and multiply it by 27, and that angle would be 54. Again, the two angles added together need to add up to be 90 degrees because they were complements. If they don't, you've done something wrong and you need to go back and rework it.